Welcome. I'm Mr. Mano. I'm so excited because this is the very first lesson of the year. We're going to start out by answering the focus question, what is physics? So we're going to talk about physics, what it is, and why it's so important or relevant to our lives. So in this lesson, we're going to define physics. We're going to give some examples of physics around us. And we're also going to talk about units. We're going to talk about why units are so important, and then the difference between fundamental and derived units. Before we do that, I'd like us all to take a moment and think about this question. What do you expect to learn in physics this school year? So just a quick intro on these notes. Anytime you see that blue box with the pencil icon, that is where you're going to respond on these slides. So you'll see a question on a slide, and if you see that blue box, that means that's where you respond. Let's take a moment, answer that question, and when you're ready, you can move on. So physics, in the abstract definition, is the study of the physical world as well as the universe that we live in. It explains everything from the motion of objects to energy and kinetic and potential. We're going to learn all about that this year and how energy is conserved. We're going to learn about electricity, including static as well as current electricity, how we power our homes or light our homes. We're going to talk about waves, including light waves and sound waves, and we're going to also talk about magnetism. And then we're going to essentially learn, or we're going to set out with the pursuit to learn about the world and the universe that we live in. So again, what is physics? Physics is the branch of science that studies the physical world. Everything from the infinitesimally small, really small microscopic objects such as subatomic particles, right? You may recall from previous science classes that those are electrons, protons, and neutrons. And we're also going to study really large objects such as galaxies. It's essentially the study of matter and energy and how they interact. I like to think as physicists of really curious, inquisitive people, and essentially, if you're a physicist, you're thinking questions like, why do objects behave the way they do? Why does the moon move? How does the moon move? Why do stars shine? How do I see that light? Questions like that is what makes a physicist a physicist. And essentially, all scientists hope to find better explanations and describe those phenomena and gain a better understanding of how our universe behaves. So I would like us to take a moment and think about what physics questions you are curious about. What are you curious about learning this school year? And then when you're ready, you can put it in the box below. Okay, so let's talk about some common misconceptions, because there are quite a bit of common misconceptions that people have. When I first mention physics to someone, or when you first hear the word physics, you may be thinking about math problems. You may be thinking about those complicated equations and formulas. Although physics does involve math problems, solving math problems and using equations, it's more about the laws and theories that help explain and understand the world that we live in, right? That is essentially at its core what physics is. It's essentially having a question about the world that we live in and then seeking to gain a better understanding of that phenomena. So I know that as I've been talking, you've probably been thinking about some physics phenomena around us. We all come with some prior knowledge of physics because we are existing in this world, right? So what do you already know about physics? And then what do you hope to know? What do you want to learn in physics this year? And let's go ahead and respond in that blue box. So again, can't really stress this definition enough. Physics is the branch of science that studies matter and energy and how they interact. Physics is not some abstract concept, right? It's not just numbers on a page. Physics is all around us all the time. Physics doesn't stop, right? So I already gave some examples. Let's try to come up with some other examples of physics that you've experienced in your everyday lives. Okay, so let's try to answer this question. When you wring a cloth, you twist it, right, and the water comes out. It's pretty simple phenomena to explain here on Earth. We know that that water would fall down due to the force of gravity. I want us to think though, what do you expect would happen if you would try to wring out that cloth in zero gravity? An example of that would be if you were to take this into outer space and try to wring it out. So let's think about that and try to come up with some explanation of what would happen. Now that we have a hypothesis, let's go ahead and watch the video and we can see if our hypothesis was correct. Once you finish watching that video, we can go ahead and answer these questions. Why can't Hatfield dip the washcloth in a bag full of water? And what does the water do and why? Again, let's go ahead and respond in that blue box. Okay, so measurements. I said before that those observations of physical phenomena are the most important aspect of physics. However, we do have to be able to record our observations, right? So we know that those observations are an important part of the scientific method. We come up with a hypothesis, and that hypothesis is either accepted or rejected based on how well they explain observations about the world that we live in. Some observations are not as good as others, right? Some, such as the plant turned brown, are what we call qualitative. Those qualitative observations do not have any physical quantities associated with them, so there's no numbers involved, right? There's some other types of observations that would have physical quantities associated with them. Those are called quantitative observations. Quantitative observations are generally considered more useful to scientists. So those quantitative observations are more useful to scientists, even if they're an estimate, because scientists usually make quantitative measurements in every experiment that they do. So let's try to think about some examples of qualitative measurements. So again, qualitative are not quite as useful as quantitative, right? They don't have any physical quantities associated with them. So let's think about the following pair of observations. A, when the volume of a gas is decreased, its pressure is increased. Or B, when the volume of a gas is reduced from 2.0 liters to 1.0 liters, the pressure increases from 3.0 atmospheric pressure to 6.0. Right, so let's think about that and try to explain or tell me which one do you believe would be more useful and why. So again, accurate measurements are a vital tool for doing science. Having a consistent set of units to measure something is absolutely necessary, right? I can't really stress this enough. Numbers are pretty useless unless they're accompanied with some type of unit, right? So physicists and all science in general use what we call the International System of Units. That is the SI system, or you may have heard it called the metric system. The metric system is really convenient because the units of different size are related by powers of 10. So it's very consistent. If we think about what we commonly use in our everyday lives here in America, we use things like inches, feet, and yards for length. And it doesn't quite make as much sense. It's not as consistent as the metric system. If you think about how many feet are in a yard, you may or may not know that that's 3. Most likely we know that there's 12 inches in a foot, but again, it's not really consistent, right? So that is why we really want to keep with something really consistent. Also, another really good reason to use the metric system is that most of the advanced world uses the metric system for science, for communicating science, right? So if we want to be able to communicate with other countries about the science that we conduct in our country, we should be on board with what they are also using. So really important here, guys. We will become familiar with the metric system throughout this school year. So the metric system has physical standards for length, mass, and time, and these are what we call fundamental units of measure. So the fundamental unit for length is the meter, denoted with lowercase m, and you can read about where the meter came from, but it's not too important. Again, we can make up any type of measurements. It's just a way to measure something. Where it comes from is not that important. The standard unit of time, hopefully we're more familiar with this. It's the second. Again, you can read where the second originally came from, but we should know that the second is denoted with lowercase s. The standard unit for mass would be the kilogram, and again, you can read where the kilogram came from. It's not too important. Hopefully, this will help you gain a better understanding that these units don't come from anything special, right? It's just a way to measure something, and we are also going to have to be able to convert between different types of units. So again, the kilogram is denoted with kg, and the smaller unit for mass, which is the gram, is lowercase g. So really important. Let's write down what are those SI units for distance, time, and mass. These are probably going to be the 3 most commonly used units throughout this school year. So meters, seconds, and kilograms are important, and although they are probably the 3 biggest units that we're going to be using this school year, they're not the only units, right? So just as an example, speed is how, if you wanted to know how fast something is going, it's how far it traveled, the distance it traveled over the time it took to do so. So that would be measured in meters per second. Meters per second is what we call a derived unit because it came from a combination of those fundamental units. So really quickly, let's write down what is the difference between a fundamental and a derived unit, and then let's try to give an example of each. All right, so you guys are doing amazing. We're almost to the finish line. I would like us to think about, again, those quantitative observations, those observations that have physical quantities associated with them and that are really particularly useful to physicists. So let's go ahead and read these observations, and please go ahead and tell us which ones are quantitative observations. So this was a physics meme that was created in our physics class last year. I love it because can't really stress this enough. Units are the most important thing in physics. Units, units, units. Again, those numbers are pretty useless unless they're accompanied with that unit of measure, right? Because what are you talking about? 100 millimeters or 100 kilometers? Those are 2 very, very different quantities. So we have to make sure, always double check your work and make sure that they have units, or else you'll end up like this person. Okay, so we've almost made it to the end. Let's wrap up. I would like us all to think about how physics is different from other sciences that you may have taken. More than likely, you've taken living environment as well as chemistry. Maybe you've taken an elective course such as environmental science or forensic science. Let's go ahead and answer these questions. How is it different from those sciences? And also, how is it similar? Because all sciences have some similarities as well. All right, thank you guys so much. You guys were amazing. Make sure that you've completed the notes and watched this video. You can rewind, you can fast forward, you can pause at your leisure and at your convenience. In the next lesson, we will talk more about mathematics and why mathematics is so vital and how it's an important tool that we use in physics to gain a better understanding of the world that we live in.